Okay, this time we're going to take a look at one of the simple torque-related problems. In this case, I've asked a question about hanging an ornament on a tree. And so, in a festive mood, we've got our tree limb here. And from the point where it's connected to the tree, I go and hang an ornament here. And the mass of the ornament is 120 grams. Pardon me. The length of the tree limb is 22 centimeters. And I'd like to know the torque applied by this ornament on the tree limb. Well, we know from our equation that torque equals our force times our distance times sine of the angle between them. Okay, well, let's see. I've got the tree limb here. The ornament is supplying a force, as we've talked about in class, that's related to its weight. So gravity is pulling on the ornament. If I draw a free body diagram, I've got mg, force of gravity down, and I've got some normal force supplied by the tree limb holding the ornament up. Now, by Newton's third law, the force that the tree limb experiences is going to be equal and opposite to that normal force. That's not a complete free body diagram because I'd also have the weight of the tree, the mass of the tree limb, being pulled on by gravity. But I don't ask for that. What I ask for is just the torque applied by hanging this ornament here. Okay, so we know that the force, in this case, is equal to the normal force as a result of supporting the ornament. So it's going to be equal to the gravitational force on the ornament. So that means for our torque, our tau is our force, which is mg, times our distance, which is there, how far out on the tree limb we are, times sine of the angle between them. Okay, well, I know that my tree limb comes straight out level like that, and that the force is downwards, so this is my force. This is d, and so the angle between them is 90 degrees. Theta equals 90 degrees. So this whole thing's going to go to 1. Okay, so at this point, all we need to do to find our torque, we know that it's mg times d, because our sine of the angle just went to 1. So filling that in, now I need the mass, which is 120 grams, but I want this in SI, so I'm going to do 0.12 kilograms times 9.81 meters per second squared times my distance, again, in SI, is 0.22 meters. And that's equal to my torque. Finally, my torque will come up to, if I calculate all that out, it should come up to something very close to 0.259 Newton meters. That is the torque applied onto this tree limb by hanging that little ornament on it.